Hi there, in this video we're going to be looking at the Einstein's box thought experiment and how we then from that get the equation E equals mc squared. So as you would imagine, Einstein's box thought experiment involves a box, and on one side of the box there is a lamp, and that lamp emits a photon of light, and that photon of light travels across the box and collides with the wall of the box on the other side. When the photon of light is released from the lamp, it gains momentum, and the momentum gain of that photon is equal to the energy of the photon divided by the speed of light. Now, when the photon gains momentum, the box is also going to gain momentum. It's going to recoil, just as a gun recoils when you fire it, so is the box. And the momentum of the box is going to be equal, I'm calling that PB, momentum of the box. That's going to be equal to the mass of the box times the speed at which the box moves. Okay, and the size of these two forces, their magnitude, not forces, sorry, and the sizes of the momentum, they're going to be equal to each other. So we can say that E over C is equal to mv. And the size of the momentum of the photon is going to be the same as the momentum of the recoiling box. So, let's have a think about how far the box and the photon travel. I'm going to call the distance travelled by the box d. Okay, that's by the box. And L I'm going to call the length of the box. And this happens to be the same distance as the photon travels. It travels from one side of the box to the other. It travels distance L. Okay. So distance travelled by the box. Let's have another think about that. That is equal to the speed that the box recoils at times time, and the time is for this happening is equal to the length of the box divided by c, because that's how long it takes for the photon to travel from one side of the box to the other. So we can replace Vt by L over c. Okay. Now we're going to take moments here, if you like, a sort of simple moments calculation. So on one side we've got mass times distance for the box, mass of the box, distance moved by the box, and on the other side we've got mass of the photon times distance moved by the photon. Okay, and they're equivalent. So what we're going to then do is substitute in for d, VL over c. We're going to put that V times L over c in for d. And that's equal to L. Now we know from our equation up here that mv is equal to E over c. So if I just move this down a little bit, we can plug that into our equation here. E over c times L over c equals L, and we can then cancel some L's as well. So we're then left with E over c squared. I hope you don't mind me combining those two c's there. They're effectively two c's times together as denominators is equal to m, and it's very easy to see where this is going. If we bring the c squared up to the top times both sides by c squared, we end up with the equation E equals mc squared. So what that shows us is that the energy of the photon is absorbed by the box in the form of extra mass. That the energy that the photon has when it hits and collides with the far side of the box, that energy is converted into mass, and what that then does is it keeps the centre of mass of the box in exactly the same place. The box is a sealed system. Its centre of mass can't change, it can't move. So in absorbing mass from the photon, it keeps the centre of mass in the same place.